Ladies and gentlemen, imagine a city where energy is limitless, transportation moves without delay, and factories think faster than humans. Picture a place where innovation doesn't wait, it evolves every day, where technology and people work together to create a trillion-dollar economy. Austin, Texas is becoming that reality. A living, breathing system of progress, efficiency, and unstoppable growth. What if I told you that this city isn't just building for today, it's designing the future? Stay with me, because what comes next will redefine how we think about cities, industry, and the way we live. The vision behind a trillion-dollar plan centered in Austin, Texas, is rooted in first principles thinking, long-term infrastructure building, and a belief that cities can be redesigned for efficiency, sustainability, and human progress. Austin is not just a location, it is a platform. It represents a convergence of talent, energy independence, advanced manufacturing, artificial intelligence, and next-generation transportation. The strategy focuses on building an ecosystem where innovation compounds over time, turning a single geographic region into one of the most productive economic engines in the world. And at the core of this plan is advanced manufacturing at an unprecedented scale. Instead of fragmented supply chains spread across continents, the model prioritizes vertical integration. Raw materials processing, manufacturing, software development, and logistics are brought closer together. This dramatically reduces cost, energy waste, and time. Factories are designed not as traditional industrial buildings, but as highly automated systems powered by renewable energy, optimized by real-time data, and continuously improved through machine learning. The result is not just faster production, but smarter production that improves itself every year. And energy is another foundational pillar. A trillion-dollar economy cannot rely on outdated grids or volatile fuel sources. The Austin strategy emphasizes large-scale renewable generation combined with massive energy storage. Solar battery systems and intelligent grid software work together to create a stable, resilient energy backbone. This allows factories, homes, and transportation systems to operate with minimal downtime and near-zero emissions. Energy becomes abundant, predictable, and affordable, unlocking exponential economic growth. And transportation is reimagined as a fully integrated system, rather than isolated modes. Electric vehicles, autonomous driving technology, and high-efficiency logistics networks converge to reduce congestion and increase productivity. Commutes become shorter, freight moves faster, and urban space is reclaimed from inefficient infrastructure. When transportation becomes safer and cheaper, people gain time, cities gain space, and businesses gain speed. This shift alone has the potential to unlock hundreds of billions of dollars in economic value. And artificial intelligence plays a central role across every layer of the plan. From factory automation to traffic optimization, from energy forecasting to robotics, intelligence is embedded directly into physical systems. Instead of software existing separately from the real world, it becomes inseparable from it. This creates a feedback loop where data improves, machines generate better data, and the entire system evolves continuously. Austin becomes not just a tech hub, but a living laboratory for real-world AI deployment at scale. And housing and urban development are also approached differently. Instead of expanding outward endlessly, the plan focuses on density done right. Efficient construction methods, modular designs, and sustainable materials reduce costs while increasing quality. Communities are built around walkability, access to clean energy, and proximity to work. When people live closer to where value is created, productivity rises and environmental impact drops. Housing becomes a catalyst for growth, rather than a bottleneck. And talent attraction is the final multiplier. A city designed around innovation, affordability, and quality of life naturally draws engineers, builders, artists, and entrepreneurs from around the world. When high-skilled talent clusters in one place, collaboration accelerates. New companies form, ideas spread faster, and breakthroughs happen more often. Austin's culture of creativity combined with a relentless focus on execution creates a rare balance between vision and results. And this trillion-dollar plan is not about short-term profits or symbolic projects. It is about building systems that scale, endure, and improve over decades. By aligning manufacturing, energy, transportation, AI, and urban design into a single coherent strategy, Austin is positioned to become one of the most economically powerful regions on the planet. And this concentration of talent feeds directly into a culture of speed and experimentation, where ideas move from concept to prototype to large-scale deployment faster than anywhere else. Failure is treated as data, not defeat, and every iteration pushes systems closer to peak efficiency. This mindset transforms Austin into a place where innovation is not occasional, but continuous, built into the rhythm of daily operations. Products, processes, and even policies evolve in near real time, guided by measurable outcomes rather than tradition or bureaucracy. An economic value in this model is not extracted, it is multiplied. Each improvement in manufacturing efficiency lowers costs across multiple industries. Each advance in energy storage stabilizes not just factories but entire communities. Each breakthrough in automation frees human effort for higher-level problem solving. This compounding effect is how a regional strategy scales into a trillion-dollar impact. Growth is not driven by speculation but by physical output, real productivity, and systems that get better with use. And education and workforce development are tightly integrated into this ecosystem. Learning is aligned with real-world needs, blending engineering, software, robotics, and applied sciences into practical training pathways. Instead of preparing students for jobs that may not exist, the system evolves alongside industry, ensuring skills remain relevant. Apprenticeships, hands-on labs, and direct collaboration with production facilities shorten the gap between knowledge and execution. The city effectively becomes a continuous learning machine, upgrading human capital at the same pace as its technology. And capital flows into Austin not just because of incentives but because the fundamentals are undeniable. Predictable energy costs, streamlined logistics, and access to top-tier talent reduce risk while increasing upside. Investors are drawn to environments where innovation is systematic rather than accidental. As more capital enters, infrastructure improves, attracting even more builders and long-term partners. This creates a reinforcing loop where confidence fuels construction and construction fuels confidence. And supply chain resilience is another critical advantage. By localizing key components and diversifying sources within the region, the system becomes far less vulnerable to global disruptions. When external shocks occur, production adapts instead of stopping. This reliability is invaluable in a world defined by uncertainty. Businesses operating in Austin gain the ability to plan years ahead, knowing that energy, materials, and transportation are stable and scalable. And environmental sustainability is treated as an engineering challenge, not a marketing slogan. Emissions are reduced by design, not offsets. Waste heat is captured and reused. Materials are recycled back into production streams. Water usage is optimized through smart monitoring and closed-loop systems. These efficiencies lower operating costs while preserving natural resources, proving that economic growth and environmental responsibility are not opposing forces, but complementary outcomes of good design. And the digital and physical worlds continue to merge as infrastructure becomes increasingly software-defined. Roads, power grids, factories, and buildings are monitored and optimized through unified platforms. Predictive maintenance replaces reactive repairs. Downtime shrinks. Performance becomes measurable at every level. This visibility allows rapid decision-making and constant improvement, turning complexity into a competitive advantage rather than a liability. And as the ecosystem matures, entirely new industries emerge. Robotic services, autonomous logistics networks, advanced materials, and AI-driven design tools find a natural home within this environment. Startups can plug directly into existing infrastructure instead of building everything from scratch. This lowers barriers to entry and accelerates innovation across sectors that traditionally move slowly. And the social impact of this transformation is equally significant. High-quality jobs, affordable energy, and efficient transportation raise living standards across income levels. Reduced congestion and cleaner air improve public health. Time saved through automation and smarter infrastructure is returned to people, enabling creativity, family life, and entrepreneurship. A city optimized for productivity also becomes a city optimized for human potential. And over time, Austin's model becomes exportable. Technologies, processes, and policies proven at scale can be adapted to other regions around the world. What begins as a local strategy evolves into a blueprint for modern industrial civilization. The trillion-dollar valuation is not a single milestone but a reflection of cumulative progress across countless interconnected systems, each reinforcing the other, each designed to scale, adapt, and improve as the future unfolds. And the expansion of Austin's ecosystem extends beyond industrial and technological advancements into a holistic redesign of urban life where every element of infrastructure, public service, and mobility is optimized for efficiency, sustainability, and scalability. Streets, utilities, and buildings are no longer static elements but dynamic systems embedded with sensors and intelligence constantly gathering data and adjusting to real-time conditions. Traffic flows are predicted and redirected proactively. Energy consumption is balanced automatically across neighborhoods, and public services respond in a fraction of the time previously possible. This responsiveness transforms the city into a living organism capable of learning and evolving in ways that traditional urban planning could never achieve. And healthcare, a critical pillar of any thriving community, is integrated with technology and data to improve outcomes while reducing costs. Remote diagnostics, predictive algorithms, and automated logistics for medical supplies create a system where care is delivered faster, more accurately, and more efficiently. Hospitals operate as intelligent hubs connected to the citywide network, anticipating demand and allocating resources before bottlenecks emerge. The convergence of AI, automation, and local manufacturing ensures that essential medical devices and equipment are produced and distributed without delay, creating resilience in both normal and crisis scenarios. And mobility continues to be redefined at every scale. Personal transportation, public transit, freight logistics, and aerial mobility converge into a seamlessly interconnected network. Electric vehicles dominate not by regulation alone, but through systemic efficiency and cost-effectiveness. Autonomous systems reduce human error and maximize throughput on roadways. High-capacity on-demand transit dynamically adapts to population patterns, ensuring minimal wait times and optimal resource use. Even last-mile logistics are automated, reducing congestion and emissions while accelerating the flow of goods throughout the city. Mobility becomes an enabler, transforming time previously lost in transit into productive activity, creativity, or leisure. And public spaces and community design are engineered with the same precision as factories and power grids. Green areas are strategically placed to manage water runoff, reduce urban heat islands, and support biodiversity. Energy-efficient lighting and smart sensors enhance safety while minimizing consumption. Recreation, work, and residential spaces are interwoven in ways that reduce commute times and maximize engagement. When the city functions as an integrated system, quality of life and productivity increase simultaneously, demonstrating that urban planning can scale human potential alongside economic growth. And the synergy between private industry, public infrastructure, and community institutions is reinforced through data transparency and shared objectives. Open APIs, collaborative platforms, and interoperable systems ensure that new innovations are rapidly integrated into existing networks. Companies are not isolated. They participate in a living ecosystem where lessons learned in one sector propagate across others. This approach breaks down silos, accelerates problem-solving, and reduces duplication of effort, creating compounding returns on every investment in technology or infrastructure. And sustainability is embedded at every level, from materials sourcing to energy use to waste management. Buildings are constructed using modular, recyclable components. Factories are designed as closed-loop systems where every output is either reused internally or returned to the supply chain. Energy storage and generation are distributed to maintain stability, even under peak demand, and excess capacity is available to support critical services or spur further economic activity. Water, air quality, and soil health are monitored continuously, ensuring that industrial growth does not come at the expense of natural ecosystems. This creates a blueprint for cities that are both prosperous and ecologically responsible, proving that scale and sustainability can coexist. And education and workforce development are treated as continuously evolving systems rather than static institutions. Real-time labor data informs curriculum design, while partnerships between training centers, universities, and industry hubs provide immediate hands-on experience. Automation does not replace humans. It frees them to engage in higher-value tasks. Individuals are empowered to learn, adapt, and contribute at the pace of technological change. This results in a talent pipeline that is both deep and flexible, capable of sustaining the exponential growth of an ecosystem designed for constant improvement. And cultural and creative industries are woven into the fabric of this high-functioning system. Innovation is not confined to engineering alone. Art, design, media, and community initiatives enrich the environment and attract a diverse, vibrant population. Public spaces, architecture, and cultural programming are all designed to inspire engagement, foster collaboration, and encourage the cross-pollination of ideas. When creativity intersects with technology and infrastructure, the city becomes not only a center of productivity, but also a magnet for global talent, further accelerating innovation. And the trillion-dollar vision is realized through relentless iteration. Every component of the city, energy, manufacturing, transportation, healthcare, education, culture, is continuously monitored, analyzed, and improved. Feedback loops ensure that small gains compound and systems evolve without waiting for external intervention. Predictive analytics anticipate demand, prevent bottlenecks, and guide resource allocation, while machine learning algorithms optimize both operational efficiency and human experience. This continuous improvement is not sporadic. It is baked into the DNA of the ecosystem, creating a city that grows smarter, faster, and more resilient each day. And the resulting environment transforms the economic, social, and ecological landscape. Austin becomes a model for how interconnected systems can generate exponential value. Economic output grows not only through traditional measures, but also through the invisible multipliers of efficiency, resilience, and human potential. Social well-being rises alongside industrial capacity, proving that progress is most powerful when it is holistic. Every aspect of life, work, play, mobility, learning, and creativity, is optimized to contribute to a unified, high-functioning ecosystem, capable of sustaining growth, innovation, and prosperity at a trillion-dollar scale. And the economic transformation in Austin extends beyond infrastructure and technology into a reimagining of financial systems and investment flows that are deeply intertwined with the city's operational fabric. Capital is allocated dynamically based on real-time performance metrics, rather than static forecasts, ensuring that resources are concentrated where they generate the greatest return in productivity, sustainability, and societal benefit. Traditional financial models are augmented with predictive analytics that anticipate demand, identify inefficiencies, and guide investment with precision. This approach reduces risk, accelerates growth, and aligns monetary incentives directly with tangible progress. And entrepreneurship thrives in this environment because barriers to entry are minimized while access to advanced infrastructure is maximized. Startups can tap into shared resources for manufacturing, energy, logistics, and software, allowing them to iterate faster and scale sooner. The feedback loop between innovation and execution shortens, creating a rapid cycle where ideas evolve into market-ready solutions with unprecedented speed. This produces a fertile landscape where breakthrough technologies emerge regularly, ranging from autonomous systems to next-generation materials, each layer reinforcing the others and increasing the overall system's resilience and adaptability. And infrastructure itself evolves as a living system rather than a static backdrop. Buildings, roads, utilities, and energy networks are all monitored, analyzed, and optimized continuously. Predictive maintenance prevents failures before they occur, sensors track resource usage in real time, and adaptive algorithms dynamically balance loads across the system. Factories, offices, and residential areas communicate with the city grid, adjusting energy consumption, transportation schedules, and waste management to maximize efficiency. This integration transforms the urban environment into a responsive, self-improving organism, where efficiency is measured not just in cost savings, but in time reclaimed, emissions avoided, and human potential unlocked. And logistics and supply chains are redefined as part of a holistic ecosystem, rather than a collection of discrete operations. Autonomous freight networks operate in synchrony with electric vehicle fleets and intelligent traffic management systems, ensuring rapid delivery while minimizing energy use and congestion. Localized production hubs reduce reliance on distant suppliers, increasing resilience and shortening lead times. Materials are tracked, recycled, and repurposed in closed-loop systems that reduce waste and environmental impact. The result is a supply chain that is not merely robust, but adaptive and anticipatory, capable of responding to fluctuations in demand or disruptions with minimal friction. And education and workforce development are deeply embedded into the city's operational framework, creating a feedback loop where learning is both applied and continuously updated. Training programs evolve alongside industry needs, using real-world data from factories, transportation networks, and energy grids to inform curricula. Apprenticeships, hands-on labs, and direct integration with active projects allow students to contribute meaningfully from day one. Skills are not taught in isolation but in context, preparing a workforce that can operate and improve complex systems, innovate autonomously, and adapt to technological change as it happens. The city becomes a living classroom, continuously producing talent capable of sustaining exponential growth. And public services are enhanced through the integration of advanced monitoring, automation, and predictive analytics. Emergency response systems anticipate incidents, allocating resources before crises escalate. Energy and water distribution networks adjust in real time to usage patterns, preventing shortages and ensuring reliability. Healthcare delivery is optimized through AI-driven diagnostics and logistics, allowing care to be administered more efficiently and with greater accuracy. Public safety, urban mobility, and social services all operate within a cohesive data-driven framework, creating a quality of life that scales with population growth rather than being constrained by it. And sustainability is approached as a systemic opportunity rather than a compliance requirement. Every layer of the ecosystem, from construction to transportation to energy consumption, is designed to minimize environmental impact while maximizing output. Renewable energy generation is seamlessly integrated with storage and distribution networks, ensuring that power is both abundant and reliable. Emissions are reduced by design through electrification, automation, and efficient resource management. Waste streams are captured, repurposed, or reintegrated into production, creating a circular economy where resources continuously cycle through the system rather than being discarded. The city demonstrates that environmental stewardship and economic expansion are mutually reinforcing, and the culture of innovation permeates every sector. Collaboration between industry, government, academia, and community institutions is facilitated through open data platforms, shared infrastructure, and aligned incentives. Knowledge and best practices propagate quickly across the ecosystem, accelerating problem-solving and reducing redundancy. Experimentation is continuous, with small-scale pilots rapidly scaled when proven effective. The city itself becomes a laboratory for technological, social, and economic experimentation, where solutions are implemented at full scale, once validated, generating both immediate benefits and long-term insight. And global competitiveness is enhanced through strategic positioning. Austin attracts talent, capital, and partnerships from around the world, not merely through incentives, but through the inherent efficiency, quality, and innovation of its systems. Companies and individuals locate here to gain access to an environment where technological progress is not episodic, but constant, where infrastructure supports rapid iteration, and where collaboration multiplies the impact of individual effort. The region becomes a magnet for those who wish to create at scale, turning local investment into global influence. And in this ecosystem, growth is compounded by design. Manufacturing improvements, energy efficiencies, workforce development, technological breakthroughs, and urban optimization feed into one another, creating exponential returns across the economy. Every element is measurable, adjustable, and scalable, ensuring that success is not static, but continuously evolving. By integrating technology, talent, infrastructure, and capital into a single coherent strategy, Austin becomes more than a city. It becomes a model for how large-scale systems can be engineered to deliver economic, environmental, and social value simultaneously.